Hi folks, we're going to take a look at some pretty typical quadratic functions applications questions, in particular those involving the vertex form of a parabola. So let's take a look at the problem. So a rocket is launched and reaches a maximum height of 170 meters after 6 seconds. At the 4-second mark, the rocket is 152 meters from the ground. So not surprisingly, the first question I'm going to ask is to determine a function to model the height versus time. So we're looking for an equation, and we see in our problem that we're given information about this maximum height. So we should be thinking vertex form. I'm going to start by actually drawing a model of what's going on. So not surprisingly, I'm going to use the ground to represent a height of 0. It doesn't necessarily have to be the ground, but that does seem to be the most logical choice. So you could choose to work with t and h, or x and y. That's really up to you. I'll choose to stick with x and y. So again, 0 height is going to be on the x-axis, and the y-axis will represent the starting time when it was launched. Now, they don't actually tell us that it was launched above the ground, but I don't want to assume that it was launched at the ground. So let's just take this as our model for now. Okay, if it turns out that it actually was launched from the ground, that's fine. That'll come out in the work that we do. But what we do know is that at a height 170 meters, which is the maximum height, this occurs after 6 seconds. Okay, so this is what we're working with. Now, since we do have information about the vertex, we want to work with vertex form. So when you have a problem like this, the first thing you should do is just write out the general form of the equation. Don't even hesitate. Okay, so this should be the first thing you think of. Now, we know the h, we know the k, because they tell us that after 6 seconds, the rocket's at a height of 170 meters. So there's our h and k. What we need to determine is the a value. So we need another piece of information. Usually that's going to come in the form of a point. Now we are given another point because they tell us that at x equals 4, y is equal to 152 meters. So we're going to input all of this into our equation. So the y value is 152 meters. The a value is our unknown. We know that this 152 meters occurs at the 4-second mark. We know that the x value of our vertex is 6. And we know that the y value of our vertex is 170. And from this point here, we'll just solve for a. So let's bring the 170 to the other side. 152 minus 170 is negative 18. Oops, little mistake there. Let's just get rid of that. Negative 18. Okay, 4 minus 6 is negative 2. We square that. That gives us 4. And so a is just equal to negative 18 over 4, or negative 4.5. Okay, so now we have our equation, y equals negative 4.5 x minus 6 squared plus 170. Now we're not quite done, because when we're creating a model, it's imperative that we say what these variables actually represent. So in order to get full marks for a question like this, you have to specify that, in this case here, where x is the time in seconds and y is the height in meters. Okay, and we're done with that problem there. So let's take a look at another question. Okay, next question I'm going to ask is, at what height was the rocket launched? So we know that that's going to occur when the time is equal to 0. So all we have to do is take our model and input 0 for our x value. So we have y equals negative 4.5. And here we know that this is occurring when x is 0. So I'll replace x by 0 minus 6 squared plus 170. And all we have to do is evaluate this expression on the right. Okay, so negative 4.5 times negative 6 all squared is 36 plus 170. And you can stick that into your calculator and you would get 8. And let's give our answer. It was launched at a height of 8 meters. Okay, there we go. We got our second problem done. Let's now go to a third one. Here, when do you expect it to hit the ground? So again, we have to interpret what this means. Hitting the ground means the height is equal to 0. So now we again go back to our model and just replace our y value now by 0. So 0 equals negative 4.5. X is what we're solving for, minus 6 squared plus 170. And again, here we're just going to use reverse operations. So remember that when you're solving for a variable, you go in the opposite order of bed mass. So we'll take care of this addition first, bring that to the other side, gives you negative 170. Okay, just a reminder at this point that when you're solving an equation, I'm expecting to see it done vertically and always having both sides of the equation written down. So now let's divide. Let's get rid of that multiplication. So we'll divide by negative 4.5. Given that this is an application problem, the expectation is that you're going to be approximating your values. If it was a straight math question, I would expect you to keep exact answers. So 170 divided by 4.5 is approximately equal to 37.78. Okay, so x minus 6 squared. Now let's get rid of our exponent, so we have to take the square root. And yet another reminder that when you're taking a square root, you have to consider both the positive and negative possibility. Now in this case here, we may not take both answers because we know we only can deal with positive numbers, but could be that both of them will be positive. So here I'll estimate that square root of 37.78 is approximately 6.15, and now negative 6 to the other side becomes positive 6. So what this means is that x is either equal to negative 6.15 plus 6 or positive 6.15 plus 6. And so here we have negative 0.15 or 12.15. And we discard this answer here because it is indeed negative, and so we are keeping 12.15 as our only answer. So it will hit the ground after 12.15 seconds. Oh, there you go. There's our final answer. So let's go on to one last question. Right. So the next question, and the last one, will be, when else will it be at a height of 152 meters? Well, let's go back to our original question, and they tell us that after 4 seconds, it'll be 152 meters from the ground. Now, we can just solve this without really thinking about it, and here we're given a height value, so you could replace height by 152 and do exactly what we did before. Okay, so again, solve by reverse bedmass or SAMDEB. So 152 minus 170 is negative 18. Okay, divide by negative 4.5. That gives us 4. Okay, take the square root. Again, positive and negative. It's an easy one, so I won't even bother writing it down. So that's plus or minus 2. And now x is equal to plus or minus 2 plus 6. So that means that x is either equal to negative 2 plus 6 or positive 2 plus 6. In other words, 4, which was the answer that we already knew. So I'm definitely happy that we're seeing that one there, or 8. So that means that it will occur 8 seconds after launch. Okay. Now, you may have been thinking that there was another way to actually figure out the answer to this problem. It just so happened that we already knew one of the answers, which was going to give us a height of 152 meters. And what we could have done is used the symmetry of the parabola, because we know that a parabola is symmetric about the vertex. That occurs at 6. We know at 4, it's at a height of 152 meters. 2 away from the vertex, so that means 2 away on the other side at 8. we'd also be at 152 meters. Much simpler, gives us the exact same answer. Okay, folks, so again, these are very typical type of application problems involving quadratic functions in Vertex Form.